The next section in Chapter 8 is scientific notation. With scientific notation, you have exponents involved. That's kind of why it fits into this unit when we're talking about exponents. Scientific notation is a number that's written as a product of two factors in the form a times 10 to the n power, where n is an integer and a is bigger than 1 but less than 10. Bigger than or equal to 1 but less than 10. So what I mean by that, your typical standard or scientific notation number might be 5 times 10 to the 11th power. Okay? That 5, let's use that as an example. 5 times 10 to some power. 8. I said 11, but we'll use 8. 5 times 10 to the 8th power. This number right here, which is why they're using the a, okay, because that's what this is kind of like the leading number in the scientific notation number. Did you guys know that that number has to be bigger than or equal to 1, but also less than 10? Did you guys know that? No. Some of you may actually not have ever known that. I have found out today. So, in order for something to be written in true scientific notation, that leading number has to be 1 or bigger, but not bigger than 10. Do you know what I'm saying by that?
1 through 9.
Well,
because it could be 10. It just can't be
no, it can't be 10. It could be 1. It can't be 10.
It'd be less than
So it's got to be in between 1 and 10, but it can be 1. Can't be 10. Okay. This shouldn't be hard to figure out. We did this in inequalities, right? There's an or equal to, but there's not on the 10. So, all right. So our first example then is talking about if numbers are in scientific notation or not. So it's a yes or no type question here. Is each number written in scientific notation? If not, explain. Letter A is 56.29 times 10 to the 12th. Is that written in proper scientific notation? No. Why?
Because it's bigger than 10.
Right. 56.29 is bigger than 10. So no good. How about letter B? Yep. No, because 0.84 is less than 1.
Are there going to be these on one where there's
Yes.
Not this easy.
6.11 times 10 to the 5th. Is that in proper scientific notation?
Yes.
Yes. So that's all you do on those. You just look at the leading number and you tell me if it's in the range it needs to be in. Your first 3 homework problems will be just like that. Example 2. So now we're going to learn, or not learn, we're going to review how to write a number in scientific notation. This number right here, 56,900,000. We need to write that in scientific notation. The decimals here, where do I want it?
Right before, or right after the 9.
Do I want it after the 9?
No, you want it before it.
Here?
Behind the 5.
Behind the 5. Right. We need it to be right here because we need that leading number to be between,
1 and 10.
you know what I'm saying? It's got to be bigger than 1, less than 10. So we have to put it right here between the 5 and the 6. So we have to move how many places to the left?
1, 2, 3, 6, 7.
7. So it's 5.69 times 10 to the 7th power. And it's positive 7. So when we go left, it's positive. When we go right, it's negative. Okay. The exponent's positive in this case. Or you can think about it, if the number is bigger than 1, it's going to be a positive exponent. If the number is smaller than 1, it's going to be a negative exponent. So letter B, it's smaller than 1. It's 0.00985, and we have to go to the right this
So
time.
it's going to be a negative.
And how many places do I want to go to the right on letter B?
3.
3. So we're going to have 9.85 times 10. We had to move 3 places to the right, so it's negative 3. So that's how you go from standard to scientific notation. Now we're going to go the other way. We're going to move from scientific notation to standard form. Look at example 3. Write each number in standard notation. Temperature at the sun's core is 1.55 times 10 to the 6th Kelvin. So how do I write this?
You just go 6. You move the decimal 6 spots.
6 spots to the right or left?
To the right.
Right, yes. 1 point, okay, I didn't mean to
So
write
just write 155.
We're going to have to go 1, 2, and then 4 more zeros. So 155, and then we're going to add 4 zeros at the end. Put your commas where they need to go, please. You do need commas in your number. So the answer is 1,550,000 Kelvin. All right, now we're going to write the lowest temperature that was recorded in a lab is 2 times 10 to the negative 11th. So which way are we going to move our decimal this time? Left. Here's where our decimal starts at. We're going to go left 10 places. So how many zeros is that going to put before the 2? 10 zeros. So there's your very, very, very small number. All right, turn over to the back, please. All right, now we're going to talk about how we can put the numbers in order, how we can put scientific notation numbers in order from smallest to biggest. We have the masses, the following masses of parts of an atom are measured in grams. Order the parts of an atom from least to greatest mass. How can we tell? What do we need to look at first when we're looking at comparing scientific notation numbers? Where do we need to look to first? Do we look at the leading number right here?
No.
Do we look at the exponent?
No.
What do we look at, guys?
It always going to be times. Yes.
Which would be your exponent, right? We're going to look at our exponent, guys. That's where you first have to look, okay? You have to look to your exponent that is the smallest number. But keep in mind these are all negative exponents. So the bigger the negative, the smaller the number, right? So which one has the smallest exponent? Electron. So your smallest exponent is going to be your smallest number. So electron comes first. So the first thing you do is compare exponents. You find your smallest exponent, and that's going to be your smallest number. If you notice, though, neutron and proton have the same exponent. So if you have two that have the same exponent, then where do you look?
You follow the number.
The leading number, yeah.
So it goes all the way to 4 and 2.
So this is, yeah, we got 1.674, 1.672 on a proton.
So neutron would go next, right?
Proton would, because the 2 is smaller than the 4. So proton, and then neutron. So guys, the key is first you need to look to the exponent, okay, and then look at the leading number if you have an exponent that's kind of got, if you got two numbers that have the same exponent, you have to look at the leading number. Those were already in scientific notation, so we were able to just do that by comparing. The next group of numbers, though, are not. This next group of numbers, if you notice, a lot of the leading numbers are not bigger than 1 and less than 10. So before we can compare them, we have to put them in proper scientific notation. So let's start with the first number here. Okay. First number is 0.052 times 10 to the 5th. Is the decimal in the right place on that first number? How many places do we need to move it? In which direction?
2 to the right.
2 to the right. So we're going to move 2 to the right. So we're going to end up with 5.2 times 10. Now, I had to move 2 to the right. What does that do to my exponent? Does it add it or subtract it?
Add it. No, subtract it.
It subtracts, yes. So when we move 2 places to the right, we have to subtract. We move 2 places. We're going to subtract 2 from the 5, and we get an exponent of 3. Okay, so you need to remember, you can write this down if you need to. When you go to the right, you subtract. When you go to the left, you add. All right? Okay, let's look at the second number. Is the second number in proper scientific notation? Yeah. 5.12 times 10 to the 5th. What about the third number? Is that in proper scientific notation? No. Nope. We need to move how many places? To the left 1. So that's going to give us 5.32 times 10. Now what exponent is on the 10 right now?
1.
A 1. We're going left.
Yeah.
So we add 1. So we get 2. because that was 1 plus 1. Okay, 534, the last number, is that one? That's not even in scientific notation, so we got to get it that way.
So it's the decimal needs to go over to the left too.
2 places to the left, so we have 5.34 times 10. Since we went to the left,
To the second.
to the second power. So now we have all 4 of these numbers in proper scientific notation. Now, it says to order the numbers on the top. The original numbers are the ones we have to put in order. So when we write them in order, we need to go back and write the original number, not our modified numbers. So which one is our smallest number?
The first one.
5.32 times 2 to the, or 10 to.
The first one.
Well, the first one though is to the third power. Fifth power, second and second. Where's our smallest exponents? The last two, the blue and the green one right here. Those are your smallest exponents. So now compare the two numbers. The green number comes first. So the green number is 53.2 times 10. That one goes first. You have to go back and list them in their proper, the original, okay? The next number, so that crosses off our green one. All right, what do we have? Our other exponent of 2 comes next, which was 534. So that takes out the blue one. Now we got an exponent of 3 and 5. Which one comes first? Exponent of 3. So the black number comes next. 5.2. Oh, I wrote it wrong. Sorry. 0.052 times 10 to the 5th. And then that leaves us one number left here. So we get 5.12 times 10 to the 5th. So that's how we put them in order. You got to compare the exponents first, and then if you've got tied exponents, then you look to the leading number. Are there any questions on how to order these numbers? Okay, let's look at example 6. Okay, now we're going to talk about how to multiply a number by a scientific notation number. Does anyone know how to do that offhand? We just multiply these two numbers. It's not like distributive property. Okay? It's not distributive property that we do. Well, 7 times 4 is what? 28. So we get 28 times 10 to the 5th. The last part of it stays the same. All we do is change that first number.
Is that all we do?
Well, that's
It's not scientific.
exactly. Thank you, Nico. Yeah, it's not in exact scientific notation yet. Like, because when we multiplied them, that put that leading number bigger than 10. We can't have that because it's not proper scientific notation.
So put 2.8.
So 2.8, but then when I move my decimal place 1 to the left, what do? Add or subtract to the 5? Add.
Yeah, that's true.
So 6. You just got to remember, if you go to the right, you subtract that many. If you go to the left, you add that many. You just have to think opposite, guys. All right, how about 0.5 times 1.2? Do you guys know what that is? 0.6. 0.6 times 10 to the negative third power.
They can stay there.
No, it
Oh, no,
can't.
'cause it's
0.6
under
less than 1. So we need to move it one place to the right, which means I do what?
Subtract 1.
Subtract 1.
But then it'd be negative 4.
Yes, 6 times 10 to the negative 4. Because remember, when you subtract 1 to a number that's already negative, you're just making it more negative. All right? So that's how you multiply with scientific notation. I hope this is a review. Some of this, it should be a review to you. All right, thank you for listening.